Ajit Mude. I am from Priyadarshini College of Engineering Maths Department, and today I am going to share the topic group theory with you all. Okay, so group theory. Group theory. First, before going for the definition of group, we will see binary operation. What is a binary operation? Let G be a non-empty set and a binary operation on G is a function from Cartesian product G cross G to G. That it is denoted by star. Generally it is denoted by star. So star is nothing but it is a function, and the function star goes from the Cartesian product of G cross G to G. It goes, and this is called as a binary operation. Binary operation can be addition, it can be multiplication, or it can be a specific definition given in a particular problem. So that can be a binary operation. Binary operation can be defined in many ways in the problem, but generally binary operation is denoted by the symbol star and then it is defined. So as I already told you, it can be simple addition, it can be simple multiplication, it can be addition modulo 5, addition modulo 10, multiplication modulo 5, multiplication modulo 15, anything can be a binary operation. Now we will go for the definition of group. What is group? Group, let G be a non-empty set and star be a binary operation. Then the combination G and star, the combination G comma star, this combination is called as an algebraic expression. This combination G star, that is the set G, and star, that is the binary operation on that set G. This combination is called as an algebraic expression. Okay, and if this combination G star satisfies the following four properties, then that is called as a group. That is called as a group. If this algebraic expression satisfies the four properties that I am going to tell you right now. Again, a special type of group is it, abelian group. Abelian group is a group which is if this G star along with these four properties, if this G star along with these four properties satisfies the fifth property also, then that special group is called as an abelian group. Now we will move to the properties which are to be satisfied. First property is closure property. What do we mean by closure property is, if I am taking two members of group G, that is A and B, two members of a set G I have taken, A and B. If A star B also belongs to G for all members AB which belongs to G, then we say that closure property is satisfied. Here A comma B belongs to G. If I reach to A star B also belongs to G, then we say that closure property is satisfied. Second is associativity. Associative property or associativity, I require three members. I have taken three members over here of the set G, A, B, C. Three members I have taken, A, B, C. Three members of G I have taken. Now, if I do the binary operation this time, A star B star C first is equal to A star B first and then star C. If in this case I get left hand side is equal to right hand side, then I say that associative property is satisfied. In this case, I require three members, and if it is true for all A, B, C belongs to the set G, then I say that set G satisfies associativity. Third is identity element. Identity element is always represented by the symbol E. E represents identity element, and the speciality of identity element is that whenever it is taken a binary operation, that is A star E, then A remain unaffected. A star E, then if A remains unaffected, then we say that E is an identity element. Of course, this should be true for all A. This equation should be true for all members of the set G. Then it is said to be an identity element. Okay, so identity element E, if there exists E belongs to G such that A star E is equal to A for all members of G, then we say that identity property is satisfied. Identity property is satisfied. Here I would like to give you one example, and that example is A plus 0 is equal to A. 2 plus 0 is equal to 2. 2000 plus 0 is equal to 2000. Like this, 0 is an identity element for normal addition. 0 is an identity element for normal addition. Similarly, if I go for multiplication, then A multiplied by 1 is equal to A. A multiplied by 1 is equal to A. So in this case, if I go for numbers, I can say 200 multiplied by 1 is 200. 10 multiplied by 1 is 10. Anything multiplied by 1 is anything. So for normal multiplication, 1 is called as an identity element. For normal addition, 0 is an identity element, whereas for normal multiplication, 1 is an identity element. Next, fourth property is inverse element. If there exists B belongs to G such that A star B is equal to identity element E for all members of A belongs to G, then we say that A and B are said to be inverse of each other. A and B are said to be inverse of each other. So here, if I could find inverse of every element in G, then I say that inverse element property is satisfied. Inverse element property is satisfied. Remember that their binary operation should be equal to identity element. Then and then only they will be inverse of each other. Then and then only they will be inverse of each other. Okay. So if these four properties, closure, associativity, identity and inverse, if these four properties are satisfied by an algebraic expression G star, then we say that it is a group. Fifth property is commutative property. Fifth property is commutative property. That is, if A star B is equal to B star A for all the members AB belongs to G, then we say that commutative property satisfied. If four properties are satisfied, it is called as group. If fifth property is also satisfied along with four properties, then it is called as an abelian group. As I already told you, abelian group. Okay, so if five properties are satisfied, it is called as an abelian